If you ask a random person how many planets there are, the answer is often 8. While it's true that our home planetary system has 8 official members, this is only the tiny tip of the cosmic iceberg. So far, experts have succeeded in identifying some 5,000 exoplanets in more than 3,600 systems. While this search for alien worlds is always subject to the hope of one day tracking down a cosmic twin of Earth, the reality so far paints a very different picture. Many planets are bizarre celestial bodies that could not be more different from our earthly home. One exoplanet can be called unusual, even in the squadron of these strange worlds, Super-Saturn J1407b. What we have learned so far about this grotesque celestial body and which unusual exoplanets beyond that were discovered, we reveal to you in today's video. Want to learn more about the groundbreaking discoveries and unique spectacles in the universe on a regular basis? Then remember to subscribe to Simply Space and click on the bell to stay updated from now on. By giving us a thumbs up, you're motivating us and showing that we can keep you excitingly informed with the content of our videos. The Super-Saturn. An equatorial diameter of about 75,000 miles and a complex ring system composed of more than 100,000 individual orbits. These are values and numbers that Super-Saturn J1407b can only shake a stick at, because actually, the extrasolar celestial body trumps our iconic ring planet by a multiple. At a distance of about 430 light-years from Earth, J1407b is surrounded by a ring system that is significantly larger than that of Saturn. The planet orbits around a very young host star. The glistening bright celestial body was born about 16 million years ago. By comparison, our Sun was born just under 5 billion years ago. As in so many other cases, the fascinating exoplanet was not added to the star charts by direct observation. Instead, it revealed itself as part of the so-called transit method. In this indirect detection method, experts look at the changes in a star's brightness that a transiting planet triggers. The probability of observing a planetary transit at a randomly selected star is not even 1%. Therefore, one might think that the transit method seems anything but promising, but the opposite is true. By 2019, about 80% of all known exoplanets could be discovered this way. That includes J1407b, which was identified in 2012 by the Super-WASP automated search program. However, it didn't take long for scientists to notice that the observed transit was markedly different from any known pattern. For example, the light of the parent star flickered in a strange way over a period of 56 days. Immediately, the experts began to search for the background of this strange spectacle, and finally found what they were looking for. According to this, the celestial body has an oversized ring system, which puts everything known in the shade. For classification, the outermost ring of Saturn has a diameter of 597,000 miles. The ring system of J1407b, on the other hand, has an incredible diameter of 75 million miles. While the Saturn system is divided into thousands of individual ring orbits, astronomers count only 37 different rings in the case of J1407b. Because these cosmic collections of dust and ice particles absorb 95% of the starlight, they could also explain the strange, unusually long star flickering observed during the transit. Theoretically, 100 Earth moons could be formed from the matter surrounding the exoplanet. Speaking of the moon, experts actually encountered a large gap that gapes in the gigantic ring system. This circumstance indicates that the exoplanet is accompanied by a satellite about the size of Earth. This would orbit its gravitational fixed point at a distance of more than 36 million miles. Apart from its rings, the exoplanet proves to be simply gigantic. Although the exact mass of the celestial body is still unknown, it's assumed to be between 10 and 40 Jupiter masses. With an equatorial diameter of 89,000 miles, the mighty gas giant advances to become the largest planet in the solar system. Theoretically, our Earth would fit inside Jupiter over 1,300 times. the ocean planet. The year is 2009 when Zachary Berta tracks down the J1407b Super-Earth. However, it should be mentioned at this point that the designation Super-Earth refers only to the mass of a planet and not to its potential habitability. About 48 light-years from our terrestrial home, J1214b orbits a red dwarf. In terms of its radiance, the parent star is 200 times fainter than the Sun. The planet itself has about 7 Earth masses, and in terms of radius, the celestial body also trumps our home planet by a factor of 2.5. The data collected so far suggests that the exoplanet has a dense atmosphere. But that's not all. The observations of the Hubble Space Telescope show that the planet's atmosphere is possibly composed mainly of water vapor. From this, the assumption is derived that the celestial body itself consists to a large extent of water. If this exciting hypothesis should prove true one day, J1214b would become the first confirmed ocean planet in history. So far, these cosmic water worlds exist only in theory. However, whether the celestial body could also harbor life is questionable. Its equilibrium temperature is estimated to be as high as 536 degrees Fahrenheit. Inexplicable planets. What makes the 2 planets orbiting the star Kepler-70 so special is the fact that they shouldn't actually exist. Specifically, the host star is a hot B subdwarf that ended its red giant stage 18 million years ago. In 2011, the experts came across 2 exoplanets in the immediate vicinity of the star, orbiting Kepler-70 in a remarkably close orbit. According to this, the celestial bodies need just 5.76 and 8.23 hours, respectively, to completely orbit their planet star. According to the common models, however, the planets should have been annihilated during the red giant phase. Thus, planets orbiting their star at a distance of less than 1 astronomical unit are swallowed up when the star inflates to a red giant. How the 2 exoplanets nevertheless managed to escape their fate is not exactly clear. It's conceivable that the planets originally orbited their star in more distant orbits. When the glistening bright celestial body finally inflated, the exoplanets could have been slowed down and pulled inward. They would have lost their outer gas shells, so that only the massive rock cores remained. Another scenario is based on the fact that the planets developed only after the transition phase, so the celestial bodies could have formed from the material which the star had ejected before. However, researchers cannot exclude the possibility that the 2 celestial bodies once formed a large gas planet which was torn apart by the inflating host star. The Diamond Planet. It is well known that our Earth needs 24 hours to rotate once around its own axis. The neutron star PSR J1719-1438 accomplishes this task significantly faster, in just 5.7 milliseconds. About 4,000 light-years away from us, this rapidly rotating celestial body is not alone. It's accompanied by a remarkable exoplanet. The latter has a diameter of 36,000 miles and needs only a little more than 2 hours to completely orbit its grotesque parent star. Between the 2 celestial bodies lie about 360,000 miles. However, this small distance provided at first frustration amongst experts, because actually the companion should have been torn apart by the proximity to its pulsar long ago. However, it seems that the planet has such a high density that it can withstand the extreme adversities of its environment. The researchers assume that its density is at least as high as that of platinum. Therefore, it is assumed that the companion is a so-called diamond planet, that is, the core of a white dwarf that has lost most of its original mass to the millisecond pulsar. The remaining mass is mainly composed of carbon and oxygen in crystalline form. The Cotton Candy Planet. In reference to a sticky fairground treat, exoplanets with particularly low density are called cotton candy planets. Among them is WASP-107b, which is much lighter than all known gas planets. Although the celestial body is as large as Jupiter, it's 10 times lighter than the largest member of our planetary system. Therefore, it's assumed that only 15% of the total planetary mass is accounted for by the solid core. In this case, scientists were once again faced with a cosmic puzzle. For example, current models require a core of 10 times Earth's mass for such gas giants to form. The solid heart of WASP-107b, however, is only 4 times heavier than our terrestrial home. Experts can currently only speculate about the background of the planet's formation. It is possible that the exoplanet once formed at a greater distance from its host star and accumulated a lot of gas there in a short time. Subsequently, it had moved significantly closer to its star, which means that today it takes only 5.7 days for a complete orbit. The use of the James Webb Space Telescope will help to further unravel this exciting background puzzle. The Rain of Glass Planet. Some 64 light-years from our solar system, we encounter one of the most unusual weather phenomena ever in the constellation of Fox. In view of the deep blue color of this exoplanet, HD 189733b, one could think that the celestial body is repeatedly hit by heavy rains. However, the color has a completely different background. It is caused by the light reflections of microscopic glass particles whipping through the atmosphere at a speed of up to 4,350 miles per hour. But there is even more that is fascinating about this planet. It's the first exoplanet on which methane gas has been detected. The orbital period amounts to only 2 days. Due to this small distance to the host star, the surface temperature of the planet is estimated at over 1,800 degrees Fahrenheit. So far, experts have not succeeded in finding a celestial body that can be classified without doubt as habitable. The fact that we still don't have any trace of life-friendly exoplanets and extraterrestrial life forms does not mean in the reverse conclusion, however, that in this connection some promising candidates don't exist. One of these exciting candidates has the scientific name Kepler-22b. Together with you, we would like to dare an exciting thought experiment today. Assuming that this alien world is indeed capable of paving the way for the development of life, what would everyday life on Kepler-22b be like? What obstacles and complications would such a move entail? Stay tuned and make up your own mind. A second Earth? Kepler-22b was finally confirmed in the year 2010. As is so often the case, this exoplanet was not detected in a direct way, but with the help of the well-tried transit method. This indirect detection method focuses on the changes in brightness caused by a planet as it passes by its parent star. However, since such light variations can also be triggered by random events, it is necessary to detect 3 successive passages with equal time intervals between them. And since the orbit of a planet can be such that the celestial body never passes in front of its host star as seen from Earth, the probability of observing a transit at a randomly selected star is less than 1%. Nevertheless, the transit method is proving to be an extremely promising option. By summer 2019, more than 3,000 alien planets had been identified in this way. Meanwhile, observing the brightness trajectories of stars not only tells us about the mere existence of a planetary companion, but also provides a lot of information about its fundamental properties. In detail, the experts can also gain knowledge about the orbital period, the orbital inclination, as well as the planetary radius. Spectroscopic analyses, in turn, allow conclusions to be drawn about atmospheric composition, temperature, and retroreflectivity. So let's now take a look at the exciting information that has been gathered about Kepler-22b so far. About 600 light-years from our terrestrial home, the celestial body orbits a star of spectral class G5. The exoplanet takes 290 days to completely orbit its central star. In terms of its diameter, Kepler-22b trumps our blue home planet by a factor of 2.4. Therefore, it could possibly be classified as a super-Earth. However, it should be mentioned at this point that the designation super-Earth does not at all refer to the potential habitability of a planet, but only to its mass. Especially exciting, the evaluation of the orbit provided the insight that Kepler-22b moves within the habitable zone of its system. In the world of astronomy, the habitable zone describes the distance between a planet and its host star. so that water can exist there in a permanently liquid form. And it's well known that the presence of liquid water is a fundamental building block for the development of Earth-like life. Should the exoplanet now also possess an Earth-like atmosphere, its average surface temperatures would settle at a value of 72 degrees Fahrenheit. As we can see, some exciting features of Kepler-22b have already been revealed. However, the celestial body is also still overshadowed by some big questions. For example, we do not know what its mass is. Equally unclear is its material composition. In this regard, it's suspected that it could be a rocky planet, a gas planet, or even an ocean planet. These ocean worlds, whose surfaces are completely covered by water, exist at present exclusively in theory. In addition, it must be found out whether the exoplanet actually has an atmosphere, and if so, what it's composed of. The much anticipated answers to these questions are to be provided within the framework of spectroscopic measurements. Scientists hope to complete these studies during upcoming transits. A long journey. In today's video, we want to look optimistically at our cosmic relocation, so we assume that life-friendly conditions prevail on Kepler-22b, along with comfortable temperatures, adequate water resources, and an Earth-like atmosphere. We'll leave out the models that say the exoplanet practically rotates on its side. However, if this is indeed the case, it would mean that the North and South poles would each be bathed in either glaring light or constant darkness for half a year. However, there is one problem that cannot be so easily pushed aside: the enormous distance between us and Kepler-22b. Even if it were physically possible to accelerate a solid object to the speed of light, the journey would still take 600 years. So does the vast distance mean that galactic relocation would be doomed from the start? Would generations of people have to eke out a miserable existence in a spaceship without ever seeing the destination with their own eyes? Well, the current answers to these questions are not necessarily. Researchers are already working hard on new drive technologies, which would lend an undreamt of push to future space travel. And that's not all. In fact, experts are currently also looking for ways to merge the world of science fiction with reality. Just think of movies like 2001: A Space Odyssey or Passenger. When the protagonists have to bridge a large period of time in space, they allow themselves to be put into an induced cold sleep. Once the destination is reached, the artificial hibernation is terminated and the people can continue living as before. Of course, we are still a long way from realizing such a futuristic scenario. Despite this, engineers and scientists at Spacework Enterprises are already working on a project for NASA called Torpor-Inducing Transit Habitat for Human Stasis to Mars. The core of this endeavor is based on therapeutic hypothermia. Within the framework of this medical method, the body temperature is specifically lowered to 90 to 93 degrees Fahrenheit. Normally, this measure is used to prevent tissue damage to the brain. For example, if a patient has suffered a stroke. In terms of future space travel, the plans now call for astronauts to undergo several cycles, each 12 weeks long, in suspended animation. During this time, the test subjects will be fed intravenously. Their excretions will be removed via catheters. A difficult home. Even in the case where a crew actually managed to land on Kepler-22b unharmed, the most dangerous part of the journey would still be ahead. Despite all life-friendly conditions, we do not know what the gravity conditions will be like on our new home. Theoretically, it's conceivable that the gravity of the exoplanet exceeds that of our blue home planet by twice. All everyday objects would therefore appear to be twice as heavy, and even our own bodies would quickly become an unbearable burden. Let's assume that one of the astronauts on Earth weighs 165 pounds. Once on Kepler-22b, he would suddenly have to lug more than 330 pounds across the planet's surface. In order to be able to handle the basic demands of everyday life, intensive strength and endurance training would therefore be indispensable. Of course, this gravity problem would not only affect humans, but also all crops and animals taken from Earth. It is conceivable that the conditions on Kepler-22b could open up an entirely new branch of evolution. It might, for example, prove useful for human beings to develop additional limbs over the course of the time in order to be able to move better on the planet's surface. In fact, high gravity could also cause internal organs to realign in terms of location and size over the millennia. In addition, the question of the place of residence would also have to be resolved. In the case of a rock planet, this decision would probably still be comparatively simple. However, if we now deviate from our great optimism, we will face enormous challenges. If Kepler-22b were indeed an ocean planet, we would either have to build artificial islands or retreat to underwater cities. If we were dealing with a gas planet without a solid surface, a cloud city would probably be the best alternative. Bespin from Star Wars sends its regards. Finally, to bring us back down to Earth, let's not forget that a solid surface is by no means synonymous with a home conducive to life. As is well known, Venus is also classified among the rocky planets. And exactly here, the circle of our video closes. Before our neighboring planet was explored in depth, people made the wildest speculations about Earth's supposed twin, or in other words, much like we did today with Kepler-22b. Until the 1960s, it was suspected that Venus's dense band of clouds concealed a life-friendly jungle world that served as home to a wide variety of life forms. Today we know that our neighboring planet by no means embodies a twin of the Earth, but rather a red-hot, poisonous stepsister. As a result of the galloping greenhouse effect, the thermometer there climbs up to 869 degrees Fahrenheit. The surface pressure, which is 90 times higher than on Earth, is compounded by the fact that Venus's clouds consist largely of corrosive droplets of sulfuric acid. As exciting as the idea of moving Kepler-22b may seem, one thing is certain: until the exoplanet's true background is unraveled, our Earth will remain the best home for humanity. As is well known, no scientist, no matter how ingenious, has yet succeeded in developing a functioning time machine. However, this does not apply to the case of modern space research, because in fact, the James Webb Telescope should enable us in the near future to catch a direct glimpse into the primeval times of the cosmos. The recently published motifs impressively demonstrate the incomparable performance of the $10 billion device. In today's video, you'll find out which exciting formations and structures made up the pictorial prelude to the Webb mission, and which exciting areas the Space Telescope will turn to in the future. The dawn of the future. The future of modern space exploration has been quite a long time coming. After NASA, ESA, and CSA began designing the Hubble Space Telescope's scientific successor in 1996, a lot of patience was required. In fact, the development of the James Webb Telescope was not always blessed. For a short time, the US government even toyed with the idea of completely shelving the groundbreaking project. Fortunately, however, this unpleasant case was not to come to pass. Some 25 years and $10 billion later, Webb finally set off into the gigantic expanses of space on December 25, 2021. Less than a month later, it reached its intended target orbit, the so-called Lagrange point L2. From there, about 900,000 miles from Earth, Webb is expected to significantly expand our knowledge of the universe in the coming months and years. Why the launch of the telescope is often equated with the dawn of a new chapter in research becomes clear to us when we compare it with its predecessor. There is no question that we have Hubble to thank for many spectacular discoveries. The use of the explorer's floating eye has allowed countless exoplanets to be added to star charts. The iconic Hubble deep fields are still unforgotten, as are the groundbreaking insights Hubble gave us about distant supernovae and black holes at galaxy centers. Given the milestones achieved since Hubble's launch in 1990, it seems all the more impressive that Webb is up to 100 times more sensitive to electromagnetic waves than its predecessor. To vividly illustrate Webb's much-cited performance, NASA points to the following example. If the telescope were located on Earth, it could detect the heat of a bumblebee on the lunar surface from there. In detail, this technical masterpiece was designed specifically for infrared astronomy. This means that Webb can work from the red part of visible light to the mid-infrared spectrum. Instruments and tasks. To ensure that the telescope's instruments function smoothly at all times, they must be constantly cooled down. In addition to the selected target orbit, this is accomplished primarily by the powerful solar shield. On the side of the equipment facing away from the sun, therefore, frosty -387 degrees Fahrenheit prevails. The technical heart of the telescope, however, is the gigantic main mirror. Consisting of 18 hexagonal segments, it has a diameter of 21 feet. The main and secondary mirrors are coated with an extremely thin layer of gold, which also reflects very well in the infrared range. During its mission, Webb will have access to the most modern instruments of our time. These include the NIRCam, which will capture light from the earliest stars and galaxies, as well as the NIRSpec and FGS nearest spectrographs. In international reporting, one of the 4 main scientific tasks in particular repeatedly makes the headlines: the search for the first luminous objects that emerged after the birth of the cosmos and during the so-called Dark Ages. However, this gripping look into the past by no means embodies the only field of research that Webb will devote himself to in the near future. In addition, new insights into the structure-forming processes in the universe will be gained. The telescope will also be used to study the evolution of galaxies, black holes, stars, and above all, protoplanetary disks, and to understand them better than ever before. Of course, one of the most fundamental questions in human history will not be left out. Are we alone in the universe? To get closer to the answer to this age-old question, Webb will look at exoplanets and check them for their potential habitability. Before the equipment will provide us with the first scientific results, however, a little patience is required because, as we know, the research mission is just getting off the ground. The breathtaking first Webb images, which NASA published a few weeks ago, therefore, give us a kind of foretaste of all the astronomical milestones that will be reached in the foreseeable future. SMACS 0723. How to meet the high expectations of the international public, which has been waiting for months for the first spectacular images from the Webb telescope. Not wanting to put its foot in its mouth, NASA gathered a team of experienced PR professionals. With the help of the consultants, the experts finally selected 4 images and a spectrum that would visually underscore the technical capabilities of our new eye in space. The original plans of the responsible persons were to unveil the corresponding images on July 12, 2022. However, US President Joe Biden did not miss the opportunity to present one of the motifs one day early, the fascinating galaxy cluster SMACS 0723. In detail, this collection of countless galaxies is located about 4.6 billion light-years away from Earth. That Webb's first deep field is bursting with detail is unmistakable. Among the thousands of galaxies are some of the faintest objects ever observed in the infrared range. Some of them appeared invisible to the terrestrial eye until this Webb image. Given the myriad of radiant entities sparkling towards us in the image, one might think that the photo covers a gigantic area of the sky, but the exact opposite is true. In the overall cosmic context, this section is no larger than a grain of sand viewed at a distance of an arm's length. Carina Nebula. What at first glance looks like gigantic mountains and valleys, in reality embodies the edge of an important star-forming region. Dotted with countless twinkling stars, the highest peaks of this stellar cradle rise some 7 light-years into the sky. In all, the structure stretches 200 to 300 light-years. In fact, the Carina Nebula, which lies in the Sagittarius arm of the Milky Way, has also been targeted by Hubble. However, due to its technical limitations, Webb's predecessor was unable to peer into the inner reaches of this stunning structure. The infrared images provided by Webb thus reveal some areas that previously completely eluded our view. Stephen's Quintet. It's a Wonderful Life is still one of the most popular Christmas classics of our time. But did you know that the angelic figures presented to us at the beginning of the movie are based on a real cosmic compound? Specifically, it's a group of 5 galaxies in the constellation Pegasus. commonly known as Stephan's Quintet. First added to the star charts in 1877, Webb reveals to us an entirely new view of this galactic assemblage. As a result, this stunning image is composed of more than 150 million pixels and consists of nearly 1,000 individual image files. The information Webb gathers will help us see how galactic interactions may have fueled the evolutions of the first galaxies. Indeed, the conditions prevailing in Stephan's Quintet can be described in no uncertain terms as turbulent. As a result of their interacting gravity, the galaxies steal each other's stars, and even the giant tails of gas and dust keep changing galactic homes. Particularly surprising was the fact that Webb was able to detect a huge shockwave sweeping through large parts of the region. The small galaxy NGC 7318b could be identified as the cause of this brute spectacle. This galaxy plunges with a speed of a few million miles per hour in the direction of the group center, heating up the surrounding gases to several million degrees Fahrenheit. Southern Ring Nebula. Some celestial bodies undergo a spectacular end. When an old star reaches the end of its natural evolution, it begins to eject its home gas and plasma stores. The fascinating objects born in this way are called planetary nebulae, even though they have nothing at all to do with planets. NGC 3132, informally called the Southern Ring Nebula, also belongs to this group of astronomical objects. About 2,000 light-years away from our Sun, this object has a diameter of half a light-year. However, the Southern Ring Nebula has not yet reached its end. With every second that passes, it spreads out 9 more miles. The image provided by Webb allows us to peer more closely than ever into the interior of this stunning object. In particular, the white dwarf that once set the colorful spectacle in motion is clearly visible in the mid-infrared image. WASP 96b. A spectrum with symbolic character, the data collected by James Webb regarding the exoplanet WASP 96b show which milestones will be reached in this exciting field in the future. Accordingly, the instrument succeeded in demonstrating that the gas giant, 1,120 light-years away, harbors water and probably haze-like cloud structures. Spectroscopic analysis is essential to study a planet in terms of its habitability. This reveals the existence of specific gas molecules in the form of tiny variations in brightness, enabling experts to make fundamental statements about the atmospheric composition of an exoplanet. Now it's time for your opinion. Which Webb image fascinated you the most with its subject? As always, drop us your thoughts, suggestions, and feedback on today's video in the comments below. Are you in the mood for more exciting contributions on the topic of outer space? Then take a look at the other videos on our channel, which you can access by clicking on one of the images in the credits. Thanks for your interest. Take care, and we'll see you next time.